So trig functions are functions that have rules defined by the trig ratios, and the trig ratios compare two sides of a triangle. When we are using trig, we use the Greek letter theta to represent the measure of the acute angles in a right triangle. So either one of these small angles, can be represented with theta. When we do a side, we use x and y. When we do an angle, we use theta. So our three trig functions are sine, cosine, and tangent. Maybe you learned SOHCAHTOA when you were in geometry. So sine is the ratio of the opposite side of the triangle from the angle, so the side that is opposite, over the hypotenuse of the right triangle. Cosine is the adjacent side, the side next to the angle, over the hypotenuse. And then tangent is the opposite side over the adjacent side. So if we look at this triangle here, here's theta. It could be this top angle as well. I'm just looking at it from this angle. The angle, the side opposite from that angle is this side. The side next to that angle, the adjacent side, is right here. And then the side across from the 90 degrees is always the hypotenuse. If that angle would change, and we were looking at theta from up here, then side B would be the opposite, side A would be the adjacent, C would still remain the hypotenuse. So it just depends on what angle you're looking from, to find the opposite side and the adjacent side. We also have reciprocal functions. So these might be new to you. Reciprocal functions, remember a reciprocal fraction is when we take the numerator, move it to the denominator to the numerator. So that's what we're doing here. So the reciprocal to sine is cosecant, and that's the ratio hypotenuse over the opposite side. The reciprocal function to cosine is secant, so that's the hypotenuse over the adjacent side. And then the reciprocal function to tangent is called cotangent, and that would be the relationship or ratio of the adjacent side over the opposite side. So let's use those trig ratios and see if we can just set up some ratios for this triangle and then the next example. So here we have theta. So the first thing I want to do is I want to label my sides. Across the triangle from theta is going to be the opposite side, so I'm going to label that. Next to theta will be the adjacent side. And then the side that is across from 90 degrees, that is going to be our hypotenuse. Now you notice here that we only have two of the side lengths. We don't know the hypotenuse. But thankfully we have the Pythagorean theorem. And Pythagorean theorem can be used anytime to find any leg or hypotenuse of a triangle as long as we know two other sides. So if we just do a little calculation, we can find out that the hypotenuse is 34. Once we have that, then we can set up all of our trig ratios. So sine is an opposite over hypotenuse. So the opposite side is 16 over the hypotenuse, which is 34. We always reduce fractions in math, so this would become 8 over 17. Cosine is adjacent over hypotenuse. The adjacent side was 30 over the hypotenuse of 34. So cosine of theta would be 15 over 17. And tan is opposite over adjacent, so 16 over 30. So tan of theta would give us 16 over 30. We can use that information to find the angle measure. I'll refresh that in another video. So if sine theta is 8 over 17, then cosecant would be 17 over 8. If cosine is 15 over 7, then secant is 17 over 15. They're just the reciprocal functions. We're just flipping them. I just noticed I didn't reduce this fraction. Sorry. Tan was 16 over 30. That reduces to 8 over 15. So then cotan, that reciprocal, 15 over 8. Make sure that you know which trig function matches to which reciprocal function. That will be very important that you know that. All right, and then let's look at that last example. Got a ruler on the screen. What's going on? All right, here we go. So here they're giving us the cosecant of, the cosine of theta is 2 over 3. So I don't really know what that looks like on my triangle until I draw my triangle. So we know cosine is adjacent over hypotenuse. So my hypotenuse will be 3, and my adjacent is going to be 2. Now, wherever I put theta will then dictate where the adjacent side is. So I'm just going to pick one of my acute angles. I'm going to pick it to be here. That doesn't necessarily mean that my triangle is drawn to scale, but I'm just putting it there so that I can figure out the missing sides. So my adjacent side would be here, and now I can calculate my opposite side. So this would be a good time for you to pause, see if you can do this example, and then check your answers. So we'd have 2 squared plus, let's say, b squared is equal to 3 squared. So b squared would equal to 5. So b is equal to the square root of 5. So this side over here would be square root of 5. And then we can go set up our other trig functions. So if we know cosine, then secant's really easy. It's just 3 over 2. So that one's quick. For sine, we have our opposite side. So I didn't label them, sorry. Opposite, adjacent, hypotenuse. So for sine, we have opposite, square root of 5 over 3. That means that cosecant's going to be 3 over the square root of 5. Now you have to rationalize your denominator. So cosecant would be square root of 3 square root of 5 over 5. For tan, we have opposite over adjacent. So square root of 5 over 2. And for cotan, we would do the reciprocal, which is 5 over the square root of 2 over the square root of 5. We're going to rationalize that denominator, multiply top and bottom by square root of 5, and we get 2 square root of 5 over 5. So once you have 2 sides, Pythagorean theorem will help you find the third side, and then you can set up all of your trig ratios. So now we're going to combine these two things together, our trig ratios and our special right triangles. 30, 60, 45, obviously 90 is used a lot in trig, so we can put those two pieces together and we can figure out what the ratio is without knowing what the side measurements actually are. So here we have sine of 45. So I drew my 45, 45, 90 triangle. I labeled my sides A, and then hypotenuse is A times the square root of 2. So we know that sine is opposite over hypotenuse. So it doesn't matter which one of the 45s I deal with, but I label that one for you. This side over here is going to be the opposite. This side would then be the adjacent, and then this one is the hypotenuse. So if I do opposite, which has a measure A, over the hypotenuse, A square root of 2, we can see that we can simplify that into 1 over square root of 2. We would then have to rationalize that denominator, and we can find that sine of 45 degrees is equal to square root of 2 over 2. We don't even know or need to know what the lengths of the sides are in order to come up with that ratio. All right, let's try that for cosine. So same labels of opposite, adjacent, and hypotenuse. We have our adjacent over our hypotenuse. This one is also going to simplify to 1 over square root of 2. That's because the angles are the same. And then we'll rationalize, and cosine of 45 degrees is also square root of 2 over 2. Lastly, we have tangent. Tangent we know is opposite over adjacent. So our opposite side was A. Our adjacent side was also A. So tan of 45 is 1. So we got that all from our special right triangle. Let's see if we can do the same thing for 30 degrees. So here we have sine of 30 degrees. I drew my special right triangle. I'm going to then label my sides. So I know that the side across from 30 degrees is A. The hypotenuse is 2A. And the long leg is A square root of 3. So sine of 30, label all my things. So opposite would be A over 2A. That gives me 1/2. So sine of 30 is 1/2. Do cosine. So cosine, remember, is adjacent over hypotenuse. So square root of 3, A squared of 3 over 2A. My A's are going to cancel out, and I get square root of 3 over 2. And then we have tangent, opposite over adjacent. Because you have that radical in the denominator, you're going to need to rationalize, and we get square root of 3 over 3. Oh my gosh, I didn't put my angle in there. Tan of what? Tan of 30. Okay. This would be another time that I'd want you to pause the video, see if you can find sine of 60, cosine of 60, and tan of 60. Start by drawing and labeling your 30, 60, 90 triangle. So I labeled my triangle 30, 60, 90. I have A, 2A, and A squared of 3. So sine is the opposite over the adjacent, which reduces to square root of 3 over 2. Cosine of 60 reduced to 1/2. And then tan of 60 reduced to square root of 3. Sorry, someone is like outside our house. Hope that helps. Hope you have a great day. Twy.